Following on from some of the earlier videos, we wanted to create a graph where it's always perpendicular to a family of these graphs here. So we could use this, or we can just, looking at this, we can just differentiate it. So dy by dx equals 2ax here. We could use this. When we use this here, it gave us an ellipse. When we use this here, it gave us some sort of log here. Okay, so continuing from the previous video, we got to that would then take us to this, and then blah blah blah, and then you would integrate it. The point I'm trying to make here is that when you this is what we did last time. We just did this blah blah blah, and we got to this thing here where it only gave us one side. You see, let's go back to here. Hang on. Let's go back to here. So when you're here, you would separate all the variables. That would then take you to here, and then you would integrate equally to both sides. But the thing is, when you have something like this, if you're asked to integrate, 1 over x dx here, you see, by right, we should use natural log, the absolute value here. We should use the absolute value here, and we've done a video on this already. So track this down. You could do this here if you're asked to find the indefinite integral of this. You could just say the natural log of x, but by right you do need the abs here, the absolute value of x here, and I've already explained this. So by right here, when we integrate this here, we should have the absolute value here. It should be, because if you integrate natural log of x, if you integrate 1 over x, it will give you the abs. Well, you do need the abs here. Okay, you do need the absolute the abs here. So if you now get your graph plotter, you see, without the app, without the absolute value here, without this, then you're just gonna get one side. But then if you redraw the graph, it will give you this here. It takes into account the negative side as well. So by right, we should have this here and this here. Okay, and something else to note. Hang on, going back here. So going back to here, when you try and find the indefinite integral of this here, you could use a method, and that would then take you to here. Or an alternative is to do this here. Don't forget, an alternative is to do this here. Hang on. Visualize as this. Don't forget, capital A is a constant. Everything else is a constant. It's just the x that's varying. So you could do this here. Equals. Hang on. You could take all the constants out, and then that will then give you this. Okay. And then now you can integrate this bit here. So that would be the natural log. Well, by right, it should be this. But let me just keep things simple. Okay, let me just make things simple because I want to illustrate something. So that will then be this, and then you've got to times it with 1 over a here. You see, given this here, when you try and find the antiderivative of this, you can get this solution, or you can get this thing here. Don't forget this thing here. Let me just tidy this thing up here. This thing here is 1 over 2 capital A natural log of x. So when you come to integrate this here, you could get this, or you could get this. But what's going on here? Because well, the thing is, remember our theorem remember the uniqueness theorem. When two things differentiate to the same thing, then these two things must be exactly the same, but only differ by a constant. And it is true. this is exactly the same as this in a way, but you just can't see it. They are exactly the same, they only differ by a constant. Because if you get a graph plotter and plot this, and plot this, okay, keep things simple. Choose something simple, like a 2. Put the 2 in the capital A here. So if you get a graph plotter, well, the point I'm trying to make here is that there are two ways of finding the antiderivative of this. One way will give you this, the other way will give you this. But these two are exactly the same. They only differ by a constant. And then I'm going to show you that right now. Hang on, bear with me. Okay, so I don't know if you can see it properly by the. So here, this I don't know if you can see it properly, but hang on. Those two are exactly the same, but only differ by a constant. So hang on, they are exactly the same. I hope by showing you this, you can try and figure out for yourself what's going on. The blue line here and the purple line are exactly the same, but they only differ by a constant. Okay, I hope you can see this, because if you get a graph plotter and plot this, plot this thing and then plus C, and then vary the C, get C. So add 0.1 to this. Sorry, add 0.1 to this, and then later add 0.2, add 0.3, add 0.4, and so on. Later on, this graph here will be exactly the same as this. The point I'm trying to make is that these two are exactly the same, but they only differ by a constant. So by looking at this animation here, I hope you can see, because hang on, you see this here is the formula here. The purple line is this thing here. The blue line is this thing here. This A here, I'm varying A here. So I'm changing A each time. So so that will then give you this. It will look like this. So as you vary, the point I'm trying to make is that the blue line and the purple line, they're exactly the same, but only differ by a constant. Okay, yeah. I hope you understand.